Good afternoon, everybody. I'm glad and happy for being nominated for Professor V.K. Kustigi Award for Excellence in Teaching. I take this moment to thank SKSVM CET management, principal, vice principal, HOD, colleagues, my dear students, and the Namana Trust for giving me the opportunity to present in front of you under the Namana lecture series a topic called Electric Vehicles, a New Ray of Hope. So, in the meantime, since last some 6 years, we have seen lot many electric vehicles. Either it might be bikes, cars, electric buggies moving around in railway stations and in large campuses. Right? There is a lot of pervasiveness of electric vehicles in the transport sector. So these are some of the contents that we'll be discussing today. That is, what is the scope of electric vehicles? What are the associated challenges? Electric vehicle development, working principle, and what are the different types of EVs that are available, and what are the components, and some regulatory norms. Okay, if you want to set up what are the regulatory norms and some shared experience, because some of our alumni are working in some of the best industries in EV right now. So, the push for electric vehicles is in regard to the global climate agenda, that is as per Paris Agreement. The intention is to reduce carbon emissions. Okay, so this global electric mobility revolution is defined by the rapid growth, of EV vehicles. That is, since last 6 years, initially the prices of EV vehicles was very high, right? But within the 6 years, the price have gone very down, and the efficiency of electric vehicles has increased in par, right? So we can say that in every 100 vehicles sold in 2020, 2 were electric vehicles. Okay, and the falling price of the batteries and the increasing efficiencies of these vehicles has upsurged the sales, and we can see that somewhere around in 2020 some 8 million EV vehicles, global EV vehicle fleet was calculated, which accounted for 1% of global vehicle stock and 2.6% of global car sales. And why for India is in need of EV vehicles? Because India is in need of a transport revolution, right? When we say transport revolution, you can see back, once the transport system within a country is enhanced, the earning power of a country increases. That is, the GDP grows, right? Way back in 1996, and in between 2006, the Golden Quadrilateral and the National Highway System was revolutionized. In the same way, now we see the mobility, that is the transport revolution, and the current trajectory points out that running on expensive imported fuel, which indirectly intenses on air pollution, which is unfeasible, and transition from conventional vehicles to electric vehicles is a promising global strategy for decarbonizing. They use the word decarbonizing the complete transport sector. It is the only promise. So, Coming with the associated challenges, there are some few associated challenges, that is with respect to battery and customer issues and policy issues. So as of with battery manufacturing, battery is the core essence of a EV vehicle. That is, it is the most critical component, and India lacks in battery manufacturing, both in skill as well as the reserves that are required. That is, lithium ion reserves are very less. We need to depend on high import of lithium ion batteries, and India imported some 1 billion worth of lithium ion batteries in 2020. Even though the EV vehicle penetration is very negligible. Okay, so other issues related with consumers are the lack of charging stations. Okay, lack of charging stations, when we say, the company operated charging stations have fast charging process. That is, the charging what is done on your domestic meters, right, for 10 to 12 hours will be done within 1 hour on a company operated charging station. So we lack here too. That is, infrastructure of 650 charging stations were recorded in 2018 when compared to 5 million charging stations with the neighboring counterparts. That is, when you compare China, Japan, right? So we lack over there also. And due to these lacking number of charging stations, EV vehicles are not a promising system to move on a long distance. Okay, so as well as it takes some 10 to 12 hours for full charge at a owner's house. That is also a very slow process. And when compared to the conventional product, that is, the cars or bikes that run on conventional fuels are much more cheaper than the EV vehicles. That is one more constraint. And policy challenges. See, as it is in the initial stage, only 6 years, 6 to 7 years, right? So it is a capital intensive sector. That is, investment needs to be put, and later, if there are any policy changes, again the required corrections are to be made. Okay, so it looks for a long-term planning wherein the break-even and profit realization are met. Okay, lack of skilled labor. Okay, and especially the electronics involved are the backbone of this particular industry, wherein batteries, semiconductors, and controllers. Okay, we lack in these manufacturing areas. As discussed earlier, we lack in lithium and cobalt, right? Dependence on import is an obstacle for becoming self-reliant in manufacturing of batteries. Okay, coming to the development, right? It involves the introduction of advanced electronic technologies apart from electric power components. So there are several risks associated. That is, the thermal runaway of battery banks and fire. You might have heard about some incidents wherein the electric vehicles caught up with fire and there was a loss of life. Okay, so these things need to be cautiously assessed, and numerous safety aspects such as functional safety, battery charging safety, vehicle maintenance, operating, training, all these are also need to be considered. So how does a EV work? Right, initially you recharge the battery, the stored energy is used to power the electric engine, right? And other accessories and components. And this supply of power to the motor is managed by a controller. The controller gets the data from the accelerator pedal, right, which regulates the flow of power, and the electric motor transfers the electric energy into mechanical energy. Okay, it transforms the electric energy into mechanical energy, and the transmission system, okay, transmission system which transforms is responsible for mechanical power to the wheels, right? That is the movement of vehicles. And some EVs use regenerative power. Whenever a brake is applied, right, the movement of the wheels itself leads to generation of power, which is collected back and stored in the battery packs. This is the working principle of EV. There are some four types of EV vehicles. One is battery electric vehicle, that is, it is purely battery based. That is, you charge, you use, right? Once the charge is exhausted, right, you are supposed to recharge it. But hybrid electric vehicles are again different. That is, they use a IC engine. Whenever the charge gets exhausted, you can turn on the internal combustion engine and run on another fuel. Either it might be LPG, CNG, or any other fuel, right? So it is a hybrid vehicle. And the other one is plug-in hybrid electric vehicle. Plug-in, wherein you have an internal combustion engine within the vehicle, but that is not used to run the prime mover. Instead, it is used to recharge the battery bank. Okay, it is used, the internal combustion is used to recharge the battery bank. That is plug-in hybrid electric vehicles. The last one is fuel cell electric vehicles. Fuel cells, they are in a very nascent stage. That is, fuel cells use hydrogen as energy, okay, wherein the exhaust that comes is a clean air and a warm steam. That is hydrogen, that is water is dissipated, that is warm steam plus air. Here that is internal, instead of internal combustion, the fuel cell is being used. These are more efficient than the internal combustion engines that are used in hybrid electric vehicles. Okay, these are the components of electric vehicle. That is, you have the traction battery bank at the base of the chassis, and the external charging port that you see. Okay, external charging port, the auxiliary battery to accommodate the auxiliary components, the other components apart from the engine. Onboard charger. Onboard charger means the internal combustion engine which is used to recharge the battery banks in hybrid vehicles. Okay, so battery converter, motor drive. Motor drive transforms electric to mechanical energy. The electric motor, transmission. Okay, that is mechanical energy into is transformed to the wheels. So these are some of the regulatory bodies, okay, regulatory bodies that are responsible in certifying when you go for your own product. Okay, if suppose, see here, you have the batteries readily available, you have the controllers, various variant controllers are available, the transmission kits are available, everything is available, right? The only thing is for your required purpose, either it is a vehicle taking some 8 to 10 people within a large campus, or else whether it is a small moped or a car, right? If you are supposed to design for the required speed and load requirements, you can design a chassis, right, and the required components, and get them registered at these centers. ARAI, ARAI, Automobile Regulatory Authority of India, is the main certifying body. That is, all the vehicles that are available in markets are certified by ARAI, and they stand by its standards. Okay, so you have these different offices. That is, these four that you see in green are greenfield projects that have been started very recently and that have been started from scratch. They did not exist earlier, and these pink one what you see, that is ICAT, RI and VRDE, right, these existed prior, existing centers being upgraded, and these are center of excellence. That is the purple ones what you see. That is, under these centers they offer these services, okay, wherein ICAT addresses only for vehicles with battery capacity less than 1 kilowatt hour. Okay, if you are designing a vehicle, moped or any kind of a vehicle which is less than 1 kilowatt hour, right, you can approach only ICAT Manesar, which is located in Gurgaon near Delhi. Okay, so for different vehicle segments, right, either it might be passenger cars or cargo carriers, right, they have these different centers, and this ARAI is full of excellence. That is, this particular center offers standards that match with the European standards. Okay, so here you might come across EMC, that is electromagnetic conduction. All electric vehicles need to be tested for this. NVH is another aspect, that is noise, vibration and harness. How the noise of the electric vehicle, what is the noise of the electric vehicle, what is the vibration associated with it, and how is the wire harness, right? You see the wire bundle, right, moving across the system, and you have some passive safety. Passive safety means active safety is when you are active. Once the accident has happened, right, what next? Passive. Later, what happens after accident? Right, you need a seat belt. If the seat belt is there, right, seat belt, airbags, the crumple zone, right, all these come into picture. So in every center you see these passive safety this thing testing options. So the process of getting certified is known as homologation process, and these are different types of automotive industry standards that are available. That is, they are all governed by the Central Motor Vehicle rules. If you search for these, right, you will find n number of rules and standards. That is Central Motor Vehicle rules. Okay, and the size of the tire, the diameter, the width, right, everything matter. Okay, because if you see within the bikes, for different CC bikes, right, the diameter of the tires vary. In the same way, for all these aspects, that is for LPG, EMI is electromagnetic induction and electromagnetic conduction. Okay, so in this way, for all these volumes, and these are some of the standards. That is, if you go through, just Google out what do you mean by AIS 38, right, you will find what are the requirements for construction and functional safety of batteries. Similarly, EIS 156, which is L category, With L category, it means low load carrying vehicles. That is, low load carrying vehicles have less battery capacity and less charging time. Okay, so in this fashion, you can search out what are the various standards associated with it, right? These are the major things what I have shared, right? So M and N are, M is for passenger cars and N is for cargo. Okay. So you can see over here AIS 138 part 1 and part 2, wherein electric vehicle conductive AC charging system and the same for DC charging system. In this way, they have addressed every other aspect. These are students, Mr. Sachidanand Dikshit, who is a senior design engineer working at Simple Energy Private Limited, Bengaluru, and his contribution is he has designed the complete plastic panel. Okay, he is proud enough to have designed this indigenous vehicle. So these are the 21 components what he has designed, that is plastic panel design of two-wheeler. Okay, so on the day of its launch, wherein all the stakeholders who were responsible in development have signed, and on this total, it bears his signature, right? Sachin Dikshit. And the next one is Nagaraj CM. Right, he is 2016 pass out and he has worked in 3 companies. All since he left the college, he has worked in Ather, Ola, and last now with Ultraviolet Bengaluru. This is the fastest bike in India. Okay, the fastest EV bike in India, which runs for a max speed of 157 kilometers per hour. Okay, once charged, it can run in between 206 kilometers to 315 kilometers. Okay, so it is with the battery capacity of, as I was mentioning, it is with the battery capacity of 10 kilowatt hour. 10 kilowatt hour. There are some smaller products with less than 1 kilowatt hour, wherein they don't require the driving license nor even the helmet, right? So this one you can see the price of this vehicle ranges anywhere between 4 lakhs to 7 lakhs. You can Google out and see, and it is one such vehicle, right, wherein the thermal cooling system, that is the heat generated for the energy exchange, is being addressed by the airflow. That airflow itself generates the sound. So you can see with this video. So please run that video, which is on the link is not working. Just minimize this and just minimize this. Okay, and now minimize this and run on this one. Okay, yes, please. So it's a 50-second video, and you can see that as 0 to 60 is reached within 8 seconds, and 140 is reached within 16 seconds. 140. Yes. Yes, stop, sir. Okay. Come back to the presentation slide. Thank you. Please enlarge that one. Okay. So coming to the conclusion, we can say EVs are the future of mobility, right? You can pervasively use for any particular purpose, right? And there is an enormous scope for skilled employment. Okay, skilled employment, you have enormous scope, and also there is a large room for startups, right? For any specific purpose, you can come out with your own design and own product, okay, for startups. And there is also scope for research and development, how these can be improved. Okay, so this is it. Any questions, please? Please feel free. Okay, thank you.